Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at parallel and perpendicular vectors. So to do that, we need first to look at scalar multiplication. So to multiply a vector u by a scalar, so just a number, all you do is multiply each individual component by that number. See, -2, as with all numbers, is a scalar. It has magnitude but no direction. So if I want to do -2 times the vector u, I just times the x component by 2, so 3 times -2 is -6, and then 2 times -2. That's all there is to scalar multiplication. So that's important in the context of parallelism. We're just looking at when two vectors are parallel. So it turns out they're parallel if and only if their components are in the same proportion. That means that the x components are in the same proportion as the y coordinates. So this statement says if u is the vector ai plus bj, then it is parallel to v, the vector ci plus dj, if and only if a over c equals b over d. If x component over x component equals y coordinate over y coordinate. Basically, two vectors are parallel if and only if one is a scalar multiple of the other. Both the x and y components have been multiplied by the same scalar. So if we look at these two vectors u and v, clearly they are not parallel. If we look at the ratio of their x components, we get 3 over 5. The ratio of their y components is -5 over 3. Clearly these two numbers are not equal. On the other hand, for u and v down here, these two vectors are parallel. This is a scalar multiple of this. To get v, we've just multiplied u by the scalar 2. So to test it formally, we have 1 over 2, x component over x component. The y component over y component is -1 over -2. These two are indeed equal, so the two vectors are parallel. Now let's look at the dot product of two vectors. So we calculate the dot product according to this formula here. So the dot product of AI plus BJ and CI plus DJ is just AC plus BD. You just multiply the X components together, multiply the Y components together, and add them together. That's all it is. So the dot product is an operation on two vectors. So it's important in determining whether or not two vectors are orthogonal. They are orthogonal if and only if their dot product is 0. Now, orthogonal basically means the same as perpendicular. It's just that you can have vectors in 3, 4, 5, any number of dimensions. And so this idea of perpendicular is generalized. So for our purposes, because we're only now looking at two-dimensional vectors, orthogonal basically means perpendicular. So let's say I have these two vectors u and v. So I'm going to calculate their dot product, u dot v. So to do that, all I do is multiply the two x components. So the x component here is 1 because it's not written. I multiply the two y components and simply add them together. Now here I get 0. What that means is that u and v are perpendicular to each other. This statement says u is perpendicular to v. Now just note that the dot product is commutative, so I always get the same answer if I do u dot v as if I do v dot u. Alright, let's try the dot product on these two here. So if I do the dot product of u and v, all it means is I multiply the two x components, I multiply the two y components and add them together. So 6 plus -4 is equal to 2. So because I did not get an answer of 0 when I calculated the dot product, it turns out here vector u and vector v are not perpendicular to each other. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.